hydrograph. A direct runoff hydrograph resulting from 1 unit, 1 inch or 1 centimeter of constant intensity, uniform rainfall occurring over the entire watershed. The concept of unit hydrograph is based on linear systems theory and follows the principles of superposition and proportionality. In this method, for a certain amount of rainfall excess, we expect the typical shape of runoff out of this watershed, and if it's a bigger watershed, then the runoff hydrograph will have a different shape characteristics. For the role of unit hydrograph, theory in the flood protection process. Provide an estimate of stream flow given an amount of precipitation. In hydrology, it provides an estimate of direct runoff hydrograph resulting from a given excess rainfall hydrograph. Deriving a unit hydrograph. One of the key assumptions of the unit hydrograph theory is that the rainfall intensity is constant over the storm duration. However, it is difficult to find a natural storm event that satisfies this and some other assumptions of the unit hydrograph theory. The data set provided here is representative of what you will generally get from a rainfall gauge. So for the steps on how to derive the unit hydrograph, 1. We should compute the total volume of direct runoff. To do this, add all direct runoff values and multiply the sum of all direct runoff flows by the time interval in seconds or of the series as shown below. Convert cubic feet per second to cubic feet of volume. Number 2. After getting the total runoff volume, find the equivalent runoff depth by dividing the runoff volume by the basin area, as shown in the table below. For step 3, the ordinates of required unit hydrograph can simply be obtained by dividing the ordinates of direct runoff hydrograph by equivalent depth of total direct runoff. Fourth, once you get the unit hydrograph, the next step to identify its duration. In the unit hydrograph definition, the duration of unit hydrograph is the time period over which the excess rainfall occurred, as also shown in this table. For the 5th step, the conventional graphical representation of direct runoff hydrograph and the derivative unit hydrograph ordinates can be obtained by plotting the direct runoff and unit hydrograph ordinates against time axis in Excel. As you can see in the given graph, the blue one is the direct runoff and the red one is the unit hydrograph. For the conversion of runoff to stream flow, a unit hydrograph shows the temporal change in flow or discharge per unit of runoff. In other words, how the flow of stream will be affected over time by the addition of 1 unit of runoff. The unit hydrograph is useful tool in the process of predicting the impact of precipitation and on stream flow. It is the graph where flow and time is.
Good afternoon, everyone. My name is Rosemary Villamera, and today I am going to discuss about limitations of a unit hydrograph. So we have here our first limitation, which is unit hydrograph method is not applicable to areas with a major portion of storm precipitation being on form of snow. Yes, because if there are snow, there is not uniform distribution of flow within a particular area, because there are varying temperatures within an area that we cannot determine and we cannot assume that are uniform. So second, we have here principle of time invariance sometimes does not hold, as the basin characteristics will change with man-made adjustments as well as the season. Yeah, so basically unit hydrograph is composed of two theories. First, it is uniform in time, in a specific amount of time. And then the second is we have a uniform distribution of flow within an area. So as there are interventions of man as well as the season, there could be varying factors such as temperatures that could not or could limit our unit hydrograph. So third, the linearity principle is strictly valid since unit hydrographs derived from small rainfall events generally has lower peaks than those derived from more larger storms. So yes, as what I said earlier, it is unit hydrograph is defined by the time and the uniformity of the flow. So it should be linear. So if we were referring to storms, we cannot really say that the flow would be uniform within a specific amount of time. So the fourth limitation is the assumptions of constant base period for storms of same duration may not produce excessively error, since its recession curve usually approaches zero approximately. So for this fourth limitation, I'm going to show you an illustration. So here, so this is the recession curve. So as we can see here, the time is dependent also with discharge. So as we can see here that the flow, the discharge is going upwards and then it recedes from upon reaching the peak. So we can see here the quick flow, the inner flow, and the base flow is receding. So in the case of a storm, the recession usually approaches zero. So last, we have here unit hydrographs can only be applied to drainage basins with small areas only and not of larger areas. Yes, because the bigger the area of the drainage, the lesser will be the chances of fulfilling the assumptions that we have. So limiting the size of the drainage basin is considered to be 5,000 square kilometer. So beyond that, the reliability of the unit hydrograph is not that effective. So that's all, and thank you for listening.
Today, I'm going to discuss deriving a unit hydrograph. One of the key assumptions in that unit hydrograph theory is that the rainfall intensity is constant over the storm duration. However, it is difficult to find a natural storm event that satisfies this and some other assumptions of the unit hydrograph theory. The dataset provided here is representative of what you will generally get from the rainfall gauge. Now, let's proceed with the estimation of discharge using UH. It can now be recognized that the unit hydrograph is a kind of unit measure of runoff occurring as a result of rainfall of specific or unit duration. A unit hydrograph gives 1 centimeter of direct runoff, obviously resulting from 1 centimeter of effective rainfall. Accordingly, if the effective rainfall in the same duration is double, that is 2 centimeter, then the ordinates of the direct runoff hydrograph will be double. Next, estimation of discharge using UH. The procedure of obtaining hydrograph from the unit hydrograph is just the reverse of the procedure adopted for constructing unit hydrograph. To obtain direct runoff hydrograph resulting from the storm of same unit duration, multiply the ordinates of the unit hydrograph by the runoff value or the effective rainfall expressed in centimeter. Here is the sample problem. The ordinates of a 6-hour unit hydrograph for the catchment area of 1,000 km squared are given below. The storm lasted for 18 hours. The effective rainfall increments for 6-hour period are 0.6 centimeter, 2 centimeter, and 1 centimeter, respectively. Here is the graph of the given sample problem. The total volume of runoff equals the area of the hydrograph equals summation sum of two successive ordinates by 2 times unit interval. That would be all. Thank you for listening.